Good morning, Phoenix class, and welcome to today's maths lesson. I can multiply decimals. So what have we learnt so far? We've learnt that we can use some known facts to help us. So if we had 3 times 0.3, we know that 3 times 3 ones is equal to 9 ones. So 3 times 3 tenths is going to be equal to 9 tenths. And then we can draw a place value chart to represent that. So we've got a quick recap for you this morning. So if 4 times 8 equals 32, you can use your place value chart to think about what 4 times 0.8 is. Remember our STEM sentence. If 4 times 8 ones equals 32 ones, then 4 times 8 tenths will equal 32 tenths. And then think about how you are going to put that in your place value chart. Remember that we cannot have 32 in one column. That's a definite no. What we have to do is put the 2 in there, the last digit in the number, and then we'll exchange the 30 tenths for 3 ones. I'll leave you to do the rest of those. You've got the answers on the following slide so you can see how you've got it. Okay, our first problem today. How tall is the fence panel? So what do we know? We know that the fence is made up of 6 panels. We also know that each of those panels is 0.3 high, 0.3 of a meter. We could draw ourselves a bar model to help us visualize what we are going to do. So it's asking us how tall the panel is. So we could do repeated addition, adding them up as we go. Alternatively, we can do as we've got here, 6 times 0.3. So how can our STEM sentence help us? Well, 6 times 3 ones is equal to 18 ones. Well done. So 6 times 3 tenths is equal to 18 tenths. So how are we going to write 18 tenths? Can we do it like this? Are you happy with that answer? Hopefully you're shouting at your computer saying no at that point, because you're quite right. We can't have 18 in one column. But what we can do is we can take our 10 and we can exchange that 10 tenths for 1 whole 1. So then we've got 1 whole 1 and 8 tenths left. So our answer is 6 times 0.3 is 1.8. Don't forget the meters. Remember, we're not measuring elephants or in tigers or bananas. We're measuring in meters. Actually, we could have used 2 different methods. So let's just quickly recap what we've done. So there are 6 planks and they are 0.3 meters high. We can work out 6 times 0.3. So here is the method that we've just done. We know that 6 times 3 is 18. So 6 groups of 3 tenths is 18 tenths, and we're going to need to exchange. And in the diagram here, it's shown you how we are taking 10 of those tenths, and 10 tenths, of course, equals 1 whole. Oops, I put 11 there. 10 tenths equals 1. So we can exchange those for 1 whole, which leaves us 8 left. The other method is converting to fractions. This isn't quite so easy because we've not covered timesing fractions yet, but some of you might fancy a go at this. So we know that 0.3 can be written as 3 tenths. We could add these up, repeated addition, and we would get 18 tenths. Or we could just say 6 lots of 3 tenths, so 6 times 3 would also give us 18 tenths, and then we can convert that back to a mixed number and then convert that back to our decimal. Which of those two methods do you like the best? So the next part of our question is the panel is 1.2 meters wide. The whole fence is made up of 6 panels. How long will the fence be? So what do we know? We know that each panel is 1.2, and we know that we've got 6 of them. But again, we need to decide what calculation we are going to be doing. So a bar model here may help us as well. So here I've got the 6 fence panels. Each of those are 1.2, and it's asking us how long will the whole fence be? So my question mark is the length of the whole fence. Now from that, I can see that I'm going to want 6 lots of 1.2. Lots of means times, so I can do 6 times 1.2. Now, I wonder if my STEM sentence will help me here. So 6 times 12 ones is equal to 72 ones. So 6 times 12 tenths is equal to 72 tenths. How am I going to write 72 tenths? Can I do that? No, I can't. What I can do is exchange groups of 10 for ones. Now I've got 7 groups of 10 in 72. So I'm going to exchange those 7 for 7 whole ones. How many tenths do I then have left? I've then got 2 tenths left. So my answer, 6 times 1, 2, is going to be 7.2. Okay, let's go on to the next question. Here again is just showing how it is worked out. Here's another method for you. So here I've done 6 times 1. So I'm multiplying my whole 1 separately. Then I'm multiplying my 0, 2 using my STEM sentence. So that gives me 1.2. But then I must remember to add them. Again, you can use whichever method you choose. Which do you think is the best? Write and complete a multiplication for each of these representations. Let's have a look at A first of all. So what is this array showing us? It's showing us 0.1 in each of the counters, and we've got 3 rows of 4. So there's one row, and in that row we've got 0.4. 0.1 plus 0.1 plus 0.1 plus 0.1. So we've got 0.4. How many rows of 0.4 have we got? Well, there's another one. And of course, there is another one. So we've got 3 times 0.4. Let's go back to our STEM sentence. 3 times 4 ones is equal to 12 ones. So 3 times 4 tenths is equal to 12 tenths. So how am I going to write 12 tenths? I can write it as a fraction. And we know that we cannot put that 12 straight into our tenths column. That's not going to work. So we need to partition our 12. If we take 10, a group of 10 out, we can move our group of 10 into our ones column. So we are going to exchange 10 tenths, and we are going to exchange that for 1 ones. So how many tenths am I going to have left? I am going to have 2 left. So as we were saying in previous lessons, the end digit goes in the column of the denominator. So we know that this answer, 3 times 0.4 is 1.2. In B, this representation is showing us repeated addition, isn't it? So we might need a place value chart again. And let's have a think about what we are calculating. So we have 4 lots of 1.3. Can you use your STEM sentence to solve this one? 4 times 13 ones is equal to, so 4 times 13 tenths is equal to. Have a go at finishing that one off. Question 2. Use the known fact to calculate the other multiplications. Well, our known fact is 18 times 4 equals 72. So what else do I know? Well, I also know that 4 times 18 equals 72. How does that help me solve A? Well, if I know that 4 times 18 ones is equal to 72 ones, I also know that 4 times 18 tenths will be equal to 72 tenths. Then you're going to have your place value chart and think about how you are going to write 72 tenths. What's going to go in the ones column? What will remain in the tenths column? In B, we're going to switch that round the other way. So my STEM sentence could be 18 times 4 ones is equal to 72 ones. So 18 times 4 tenths is equal to 72 tenths. Again, use a place value chart, work out what goes in the ones column and what stays in the tenths column when you are writing 72 tenths. C is slightly different because 180 is 10 times more and 0.4 is 10 times less. Some of you might be able to predict what your answer will be already. But let's have a think about how the STEM sentence can help us. So if I had 180 times 4 ones equals 720 ones, so 180 times 4 tenths is equal to 720 tenths. How are you going to write 720 tenths? Finally, you've got D. And this just needs our stem sentence changing a little bit, doesn't it? So if we have 18 times 4 ones is equal to 72 ones, so 18 times 4 hundredths is equal to 72 hundredths. Use your place value chart. How are you going to write 72 hundredths? The answers are on your PowerPoint, so you can check how you got on. When you go into your practice book, you're all going to be able to complete all of these. So let's have a look at question 1 quickly first. Write 2 multiplications to match each representation. So on question 1, those counters are each worth 0.1. So we have 5 counters that way. So we can, each of them of 0.1. So that's 0.5 altogether. And we have 3 rows. So we can say 3 times 0.5. Alternatively, we could say that we have in the red circle 0.3 altogether. We've got 3 counters, so that equals 0.3, and we've got 5 columns, so 0.3 times 5. In C, you're going to do exactly the same. How many columns have you got? How many rows have you got? And that will give you your 2 calculations. Same with B and D. In question 2, my top tip is going to be to have a place value grid to help you. So this is all about our known facts. So if 3 times 4 ones equals 12 ones, 3 times 4 tenths is going to equal 12 tenths. Then you use your place value grid to make sure you put the numbers in the correct place and have the decimal point put in correctly. So the next one down would be 3 times 4 hundredths would be 12 hundredths. How are you going to write that number? Where are you going to put your decimal point? I'll let you finish those off. Question 3, write a calculation. Which calculation, gives you an answer closest to 10? So the first thing you are going to have to do is work out the answer to those 4 questions. Once you've done that, you might need to do some taking away, because I'm guessing that the writers of this question will try and be a little sneaky. So it won't be obvious which answer is closest to 10. So you might need to do 10, take away your answer, or if your answer is bigger than 10, you might have to do your answer, take away 10 to find out which is the closest. You then write the one that you've chosen in the boxes underneath, or if you're writing it out on paper, just write that sentence out so that I know that you've answered it correctly. Question 4, we've got 3 calculations there, and you are being asked to draw diagrams to show whether or not Isla is correct. So Isla says, I do not think these calculations are right. Whenever you multiply a decimal, you always get a decimal answer. Now, this is asking you to do diagrams. So you're having to prove whether or not Isla is correct. So by diagrams, you could use a place value grid like this. You could use counters like this. You could draw a number line and show repeated addition. How else could you model that? Look back and see how we've done it in previous questions today and yesterday. But the whole thing is about you proving whether or not she is right or not right. If you feel you need more practice, you've got 4 more questions here. If you're thinking, no, I don't need any more practice, in that case, you're going to have a go at the challenges. Remember, it's either need more practice or it's the challenge page. Finally, your reflection. Write 3 different multiplications with a product of 0.36. Remember, product is the answer to a multiplication question. Good luck today. Have fun.